we have a mass m, which is tied to a string, and the string has a length L, and it's whirled in a horizontal circle with a frequency f. Frequency is the number of rotations per second. Okay, so the frequency is f. And we need to calculate A, the tension in the string, speed, and angular speed. Let's begin with tension. First of all, it's a uniform circular motion. If it's not mentioned, we're just going to assume it is uniform unless and until it is mentioned otherwise. Okay, if things are going in a uniform circular motion, that means the speed is going to remain a constant. Why would it require tension? Well, notice that even though the speed is a constant, the velocity is changing because it's changing its direction. Velocity is always tangential, right? So velocity, for example, in this case is tangentially upwards. A little later in time, the velocity changes its direction, and clearly there must be an acceleration, and it can be proved very logically. In the uniform circular motion, the acceleration must always point radially. That's along the radius of the circle, so here's the center somewhere. And to provide for that acceleration, we need a force, and it's going to be tension in this example. Since it's a horizontal motion, we're pretty much going to neglect gravity, because with gravity, it's impossible to get horizontal motion. Anyways, with all this background, let's quickly calculate what the tension is going to be. If we apply Newton's second law, tension must be equal to mass times acceleration. And that acceleration is this way, and that's the centripetal acceleration. So tension force must be equal to mass times centripetal acceleration. But what is centripetal acceleration? Well, we have two formulae for centripetal acceleration. One, we have v squared by r, where v is the linear speed, or we can also substitute for linear speed. You know what we can do? We can do the following. We can say, look, the distance traveled in the linear must be equal to r times theta. This is some background you need. So this is the connection between s, r, and theta. So here's a circular, or part of a circle. So if this distance is s, and this angle covered is theta, and this radius is r, then this equation must be holding good, because that's how you define theta in radians. Okay, so you put a c over here to say it's radians. All right, now if we differentiate this, ds by dt, that's the rate of change of distance. So that's the rate of change of linear position, that is velocity, should be equal to r is not changing, times rate of change of angular position, that is omega. Okay, so we have one equation over here. So we can plug that in over here, and we'll get r squared omega squared, right, divided by r. So r cancels, so we have r omega squared. So that's going to be another equation for centripetal acceleration. So these are two equations, but notice that our question does not mention angular velocity or angular speed, nor it mentions frequency, linear speed. It mentions frequency. Somehow I must be able to derive omega and v using frequency. Well, how do I do that? Well, think about it. Frequency is in hertz. This is measured in hertz, and it's number of rotations per second. Omega is measured in radians. It's number of radians per second. I mean, it's measured in radians per second. What's the connection between number of rotations and number of radians? One rotation corresponds to 2 pi radians, right? So let me just write that down somewhere. So let's say I write it over here. One rotation should be equal to 2 pi radians. Therefore, if the frequency is, say, 5 hertz, then how many? It's 5 rotations per second, which is the same as saying 2 pi into 5 rads per second. So in general, we can say that omega is 2 pi times f. So this is the connection between angular speed, or sometimes we can say angular frequency, with the linear, with just frequency, 2 pi, because one rotation corresponds to 2 pi radians. So that's the connection we needed, okay? So we can now substitute for acceleration. I'm going to substitute this guy for acceleration. It's going to be r omega squared. And so the tension must be equal to r, which is the radius of this path, which is just the length of the string. So m times L, and omega is just 2 pi f, it's over here. So 2 pi f whole squared. So tension becomes m L 4 pi squared f squared. That's the equation for tension force. Okay, notice that we wanted to calculate angular speed and also speed. We already calculated what the angular speed is. It's 2 pi f. And we can now use this equation to calculate what the linear speed is. So the linear speed is going to be, let's write that down, it's r times omega. So it is 2 pi r times f. And notice this also makes a lot of sense. If f is 1 rotation per second, then the distance traveled will be in 1 second, 2 pi r, right? 2 pi r is the circumference. If there are 10 rotations, then the distance traveled in 1 second is 2 pi r times 10. So 2 pi r f is the distance traveled in 1 second, which is nothing but the speed. So we have solved our first problem on circular motion. Let's do some more in the next case.